Hello, my name is Chongjun Lee, and I would like to make a final presentation in reinforcement learning. Uh, my final project was about learning a policy to adjust the learning rate. Uh, it is difficult to find a good policy to adjust the learning rate, given that good policies are problem specific and depends on implementation details. So in this figure, I prepared a example of applying learning rate to each update, and we can see that it is crucial to find a good learning rate in order to find the the minimum that minimizes the loss function, and also it is important not to get stuck in the plateau or some other local minima. Uh, in the problem of learning rate, we can see that learning rate control is a sequential decision process, and also we can see that although there is some immediate reward, which is the one step decrement of the loss function, it is also important where in the final convergence where we converge to, which determines the performance of the final model. So in these two observations, there have been some approaches to learning rates within the reinforcement learning framework. Some related works includes the first, the reinforcement learning for learning rate control, which came out in 2017. And in this paper, it used actor-critic algorithm to address the learning rate control problem. And it used the history of loss values as the input to the agent, and it used the continuous action space and deterministic policy gradient. Also, another work that came out in 2016 used some various other features to represent the state, and also it used relative entropy policy search to find policy. Here's some problem definition of the project. We are given a CNN model with the MNIST setting. We want to find the at each time step we want to find the best learning rate, which is given by the policy. So we want to learn a policy which gives the best learning rate. So in here we want to minimize the loss throughout the training process, and each update the model is updated using the learning rate shown in this equation, and what we want to do is find this policy which outputs the learning rate at each update. Some proposed method in this project is that is closely related to the previous works, but I wanted to try these algorithms, make sure that it works, and also find some other parts that I can improve. And there are two approaches that I used in my project, which is the continuous action space model, which computes the continuous value as learning rate. So in here, agent will output a continuous value as a learning rate. And also, I could consider a discrete action space model, which can choose between discrete action spaces. And in here, the example is shown as this slide. Then I would like to talk more about some environment. As we learned in the beginning of the class, the environment the agent interacts with the environment. So environment in my project was a simple CNN architecture training on MNIST dataset, and the environment is represented as this box here, and our environment trains on the MNIST dataset with and the agent interacts with my environment through this output a sub t, which is the learning rate, and as a result of this action, this environment will update our model, and it will give the loss value as the reward, a loss decrement, and also it will give out the state, which represents the the learning process. So one of the problems in my project was that since learning is a non-stationary process, uh, this has some problem with our algorithm, which assumes a stationary environment. So I try to make the environment as deterministic as possible with limited number of possibilities. So in that line of effort, I try to constrain the training process so that it can resemble a stationary environment. So for example, I fixed the data set to endless data, and also I fixed the seed for the random initialization of the model, and also I fixed the order of mini-batch and mini-batch size, and also I fixed the number of iterations in one episode. So here are some IRL settings that I used. In here, the MDP is given as follows. So we have the state, which is the loss value from training process. And there can be other considerations for the features for state. So in some previous works, they could also consider some other features. But in my project, I started out with the simple state feature, which was the loss function, loss value. And then the action is the learning rate, and the actor and the critic was made with the fully connected networks, and the reward was the loss decrement for each step, and the episode is the training of one apple. And I applied actor-critic algorithm, which used the equation as below, where our update for the policy parameter theta is given by the grad log probability of the probability of our action times the advantage function, and our advantage is computed by the TD target. Then to give more detail on how I apply this, how I try to apply this method, I try to implement the actor model with the continuous action space, which output the learning rate, and the network is given as this figure, which is just a small, simple neural network. And also at the same time, there was another value critic network, which is also a simple neural network. Then for the discrete action space model, I used the learning rate, which this model chose among three options, which is which considers the default learning rate, which is the hyperparameter a naught and alpha naught, and also it can choose between the discrete action, which goes a naught, alpha naught minus half of alpha naught, or plus go into the other direction. And in this network, I used the architecture that shares the same hidden layer. It has a separate output layer which produces the action logics, which is 3, and also the value estimation. So for the current status, the model implementation, the continuous action space model was tried first, and then it didn't quite work. I had some challenges, so I also tried some discrete action space model, which I thought was simpler. But for these two models, I'm still trying to implement the networks, and I would like to share some the results and some challenges that I have so far. So for the continuous action space model, the model is being trained at the 25th episodes, and the undiscounted cumulative reward is monitored at each episode. And for hyperparameter, I tried different gamma value, was experimented, but as I show in this figure, which is the cumulative reward along the episodes, it's not quite learning, so it's the reward is not increasing. And also I tried some other hyperparameters too. So m sub theta and m sub p, which represents the frequency of updates for actor network and critic network, but it's not showing it's not showing any changes. So in order to find some problems, there is a problem with the continuous action space model, actor model, which is that it quickly goes out of the right range of learning rate. So for example, it can go to the negative number, or it goes up to really large number, so it cannot uh, update the model right. And in order to address this problem, I'm currently planning to try some functions as sigmoid function, uh, which can constrain the range of the output, and also considering penalizing the out of range output of the model. And since the continuous model didn't work so well, I tried the discrete action space model too. And in this model, I thought it would be easier to train than continuous action space model. And for this model, the model is running, but it's not showing improvements in reverse either. And I think there's some bugs in the code. So below is the models with the different gamma values, 0.99 and 0.9. And it's fluctuating, and it's not showing desirable results. So in the future, I will try to fix the model and then experiment with some different configurations. For actor model architecture is right now currently implemented with DNN, but I think I will consider the LSTM too. And also for state features, I would like to consider some other features to represent the state, which can be last layer vector of the CNN model. And also I made this chart to fill out the results that I will get in the future. So I will collect some number of episodes, the cumulative loss decrement, and converged loss and validation accuracies, so that I can compare some differences of the different configurations. If the model works well, and if I fill out the charts well, I think I will be able to make some contributions in terms of research. So for these directions, I think I will be able to use some new information for features to represent states, which were not tried before. And also, I think I expect to incorporate some switch to favor classification of certain classes. And also, I think I will be able to select some certain gradient of only selected logits. So I'll make some changes to the model so that the model behaves in the more desirable way. So that is about the updates of my final project, and I will also update when I obtain some interesting results. Thank you for listening.